Okay, so what if I told you the next huge leap in AI isn't going to be some new piece of software? What if it's a chip where the AI isn't just running on it? The AI is the hardware. We're talking about a massive shift here, from just simulating intelligence to actually physically embodying it in silicon. And this whole wild idea, it really starts with one single mind-blowing number. 17,000. That's it. That's the number. It's what this little Canadian startup, Taalas, just casually dropped on the entire AI world. And believe me, it changes, well, pretty much everything. Just kind of let that sink in for a moment. So what is that? It's 17,000 tokens. You can just think of them as chunks of words, spit out per user every single second. Now, to give you some perspective, a really fast human reader, maybe 10 tokens a second. The fastest GPUs out there, you might get a few hundred. This is a speed that is, for all intents and purposes, instantaneous. It's like having a thought and it's already written. And a number like that, well, it forces us to ask some pretty fundamental questions.
Right, so how on earth is a speed like that even possible? Well, to get the aha moment behind the breakthrough, first we've got to talk about the problem, the bottleneck. There's this massive kind of hidden inefficiency that's gumming up the works in basically every AI data center on the planet. Yeah, for like the last 70 years, pretty much every computer has been built with this deep, fundamental design flaw, at least when it comes to AI. It's basically a ghost from the 1940s that's still haunting us, and it's costing us an absolute fortune in time, energy, and just raw heat. It's called the von Neumann bottleneck, and the best way to think about it is like this. You've got the computer's processor. That's the brain, right? And it's totally separate from its memory. That's where all the data, all the knowledge is kept. We can call that the book. And this quote just nails the problem. The brain and the book are in two different rooms. So for an AI to think, its brain literally has to get up, run to the other room, grab a single page from the book, run all the way back, do one tiny little calculation, and then do that whole trip over and over, billions of times a second. It's a constant, maddening traffic jam that's baked right into the DNA of modern computing. And the cost of all that running back and forth? It's absolutely staggering. Just look at this. Up to 90%, 90, of the electricity powering those huge liquid-cooled AI data centers. It isn't being spent on thinking. Nope. It's spent on the commute, just shuffling data around. It is an unbelievable waste of energy. Okay, so this brings us to the main event. On one hand, you've got the way we've been doing things forever, simulated intelligence. You take a general-purpose GPU and you load an AI model onto it, just like any other piece of software. But on the other hand, you've got the Taalas approach, embodied intelligence. They just looked at that problem and decided, you know what? Let's just stop the commute. They basically moved the brain inside the book.
So how exactly did Taalas pull this off? Well, instead of trying to build a faster delivery truck, they just got rid of the road. They didn't just put the AI model on the chip. They made the model become the chip. And this really gets to the heart of their whole philosophy. They're saying, hey, we should stop simulating intelligence on a general-purpose computer. Instead, we should cast it in silicon. We should stop treating intelligence like it's just a temporary program, and instead give it a permanent physical body.
And here's the really cool part, how they actually do it. They take the billions of numbers, the weights that make up an AI model, and they translate them directly into a physical circuit design. The connections, the pathways, they are literally etched into the metal layers of the chip. It's a technique that basically hardwires the model's brain into a permanent, unchangeable circuit. The AI's knowledge becomes the physical structure of the chip itself. And the result of all that? Well, it's the insane performance you see right here. By completely getting rid of that memory wall, the speed just goes through the roof. An input signal just flows through the chip, kind of like electricity through a simple wire, and the math, it just happens. There's no code to run, no instructions to fetch. The actual physics of the chip is the computation. It's wild. Okay, but I know what you're thinking. This raises a huge, pretty obvious question, right? It's the first thing skeptics jumped on. If you literally etch an AI model into silicon, what in the world happens when a better model comes out, like 3 months later? This is what people are calling the immutability paradox. I mean, did Taalas just create the world's fastest disposable chip? Is this thing just an expensive paperweight the second a new, better model gets released? Well, turns out their answer to this is actually pretty clever. See, it turns out the chip isn't entirely etched in stone. It's a hybrid. Think of it as part stone, part clay.
The vast majority of the model, all that core knowledge about language, facts, and logic, that's the stone. It's permanent, it's unchangeable, and it is ridiculously fast. But then, layered on top of that, they add a little bit of clay, which is just a small amount of fast, flexible, programmable memory.
And this clay layer is the secret sauce. It's what makes the whole thing work. It handles all the dynamic stuff, like remembering what you just talked about in a conversation. And, this is crucial, it allows for fine-tuning. So you can use these little software adapters to keep that massive hardwired base model, but then tweak its behavior for specific jobs, like, say, legal analysis or helping you write code. And you do all that just by changing the software in that flexible clay layer.
But what about the stone part itself? Well, Taalas has a second answer for that. Their manufacturing process is apparently so streamlined that they claim they can go from a finalized new AI model to a brand new custom-built chip in just 2 months. That's incredibly fast for hardware. They do it by only customizing the top couple of metal layers on a mostly pre-built chip. This refresh cycle is actually fast enough to keep up with the software world, basically turning hardware into something you can update almost as fast as an app on your phone.
So, okay, let's zoom out a bit. What does all this really mean for the bigger picture? Well, it signals a massive shift for the entire industry. It feels like we're heading into a new era, where it's not just about having the most powerful general-purpose computer, but about creating extreme, purpose-built, specialized hardware. I mean, just look at these numbers. The cost of actually using an AI, what we call inference, it just completely plummets. We're going from, maybe 20 to 50 cents for every million tokens on a cloud GPU, all the way down to less than a penny. That is not just a small improvement, that's a fundamental change in the entire economics of AI.
Now, let's be clear, this doesn't mean GPUs are going away. Not at all. If you want to train a brand new model from scratch, you still need that incredible flexibility and power you get from a huge GPU cluster. But what this does is create a fork in the road for AI hardware. Training will stay in the world of GPUs, but inference, the day-to-day job of running these models for millions of users, that can now shift over to this new, hyper-efficient, specialized silicon. And when you boil it all down, it really comes back to this one core idea. We are moving from simulated intelligence to embodied intelligence. You know, on a GPU, AI is kind of like a ghost in the machine. It's just a temporary simulation running on a fancy calculator. But on a chip like this one, intelligence becomes a physical thing. It's matter, arranged in a very specific way that just inherently thinks. And that, of course, leaves us with one final, absolutely massive question. What happens to the world when intelligence becomes a utility? When the cost of a single thought gets incredibly close to zero, and the speed of that thought is literally instant, what happens next? What do we build when intelligence stops being this scarce, expensive resource and instead becomes something as cheap and abundant as electricity? That's the future a technology like this starts to make possible.